something like this. I hit go live and going live, and this stopped loading, so I thought that I am live. Now it will work? No. Like, no, for the third time I tried to go live on YouTube. So I hope it's alright now. Just Twitch chat again let me know that something is wrong. I think it works now. That was annoying, and sorry about that. I'm solving this problem. Link again goes in the chat. And then I will sometimes get suggestions from the chat about future problems, as always. N is up to 100. You need to reorder and choose some subset of them. Need to work at YouTube to correct this issue. I don't think in such a big company you can make any meaningful change, even if you notice that something is wrong. How many employees does YouTube have? 10,000. What about Google? 100,000. So you're a very, very small percentage, or actually fraction of a percentage of a company. Code Forces educational round is going on. That's correct. YouTube is subset of Google? Yes, I don't know. One company owns the other. But you should say that you work for YouTube or for Google. It's not that you're hired by Google, but you work on YouTube. All right, let's do this. It would be nice to sort those cuboids by something. And we can choose any dimension, let's say the first one out of 3. And if we do this decreasingly, we know that in this order we should take them. We should take those cuboids. Let's say that we have this. Then because I sort decreasingly, 95 should go first. Like that. Right, and now one possibility is to check if I can take all 3 in this order. That's the only possibility for that after my sort. That is, if the problem asked me if I can put all the cuboids in some order, one on the top of the other, so that the inequalities would hold true, then this would be the only possibility. Assuming that I resolve ties correctly. If there is tie on the first value, I need to decide those ties by the second value. Though C++ by default does that. It sorts tuples lexicographically by first value, if there is a tie then by second value, and so on. So it's okay to do this. Cuboids that begin. Cuboids that end. But here it's impossible because the second dimension here is smaller than that. But there can be some transitions. From the first one, after the first one, I can take this third one. It's okay to take first and then third. It's also okay to use second and then third. Those are possible transitions or edges in the graph. We will solve this either by thinking about a graph or about dynamic programming in this order. Please don't repeat your comments, your messages. Son Goku, you already suggested that problem, and I'm solving now another problem. And those are the 2 possibilities. Height is which value? The last one? The first one is the height. Here we get optimal height by taking 95 plus 45. So this option, taking first and then third, is the best. And it will give us, no, it isn't the best, it will give us 140. Are they saying that we can do everything? Can I rotate them? You can rearrange any cuboid's dimensions by rotating it to put it on another cuboid. All right, now I understand it. But then it will be much harder problem. I didn't expect that, to be honest. So let's get back to thinking, because if I couldn't rotate, if I knew that this is the height, this is second, this is third, I wanted to say this. We sort like that, just decreasingly, so like that. Now they are sorted decreasingly. And now you can do DP where for every tuple you want to know maximum height up to this thing, if this is the one put at the top, and you continue with some transitions. It will be easy quadratic DP. But if we can rearrange dimensions, that's much harder, because every tuple, it gives us actually 6 possibilities. Like if you have x, y, z, then there are 3 factorial ways to reorder those values to give us dimensions. And yeah, now it's hard to say by what we should sort the tuples, the triples. So we need to think about it some more. Also, I agree that the condition about heights isn't natural. If you stack some packages on top of each other, then it would make sense to say that width and depth, or however you call them, 37 and 53 here, those should be decreasing, but I don't see any issue in putting something at the top that would be taller. 3 possibilities, but 3 instead of 6? I think that's 6. 3 factorial is 6. This will give us xyz, xzy, y this, that, and those starting with z. That's 6. I think that the condition makes the problem easier, the one about heights? Maybe. I'm just for now judging that it isn't natural. I was watching your older videos you posted 14 days ago, a few minutes ago. Now the content is unavailable. Is this intentional? Maybe you watched on Twitch and Twitch stores it only for 14 days? That's some theory. Grab this link and you can watch on YouTube all my past streams for all the years. 3 possible heights, so 3, but you care about the order of y and z. They need to satisfy some inequalities. You did not give link for your stream on Discord? That's fine. On Discord server, that channel, anyway, once every few comments it has link to my Twitch channel, so it's enough that I just ping people there. All right, let's again think if we can choose order of packages to use. We cannot sort by first value. We cannot consider each of 6 possibilities and in some way say that we sort by all of them. Maybe it would make some sense to replicate this triple like many times. So we have this one, we have this one, and so on. So replicate each package into 6 instances, permute each of them, and sort something like that by height. That's one idea. The other is to find some other way to decide if you're given a triple, let's say 10, 25, 30, and another triple is, say, 32, 23, and 18, can we say which one will be higher? It will turn out that yes, it is possible. At least I hope so. Take all 6 possibilities and all 6 possibilities have same index and then sort. I don't know what is same index, but yeah, there are 2 ideas. One is, let's call it idea 1, replicate every triple 6 times, or actually 5 times, so there would be 6 objects. Sort all 6 times n objects. That's one idea. The other one, come up with smarter comparator to sort given n triples. This is also triples. We can investigate both. So maybe quick question to the chat, just not an official poll. Do we do idea 1 or 2? Just type 1 or 2 in the chat. Can you look at which companies ask this question? This is, blocked by default, but also it doesn't really matter. You shouldn't look at those values, at those information about companies. Every company roughly requires the same set of algorithms. And please speak English. All right, idea number 2. So decide how to sort given n triples. As I said, we look at, still out of more 2's. For those two, can it happen that 20, 25, 30 will be below this other one? Or can it happen that the other way around? Is it at all possible that we will come up with such two triples that, depending on the permutation, one will be on the top of the other, or the other way around? If it's possible, then we cannot use idea 2, if both directions are possible. But we hope that it isn't the case. So what is it here? Well, I will observe that if we have 32 here, it will be one of the dimensions. So it cannot be, this triple cannot be above this one, because 32, there is nothing greater than 32 in the first triple. Hence, I think that maybe we should sort by maximum in every triple. And we need to say that this thing can only be lower than that. Can it actually be lower than the first triple? I don't think so, because there is also 18. And 18 is smaller than everything here. On the other hand, if we look at minimum, then we also have some condition, which one goes first. And actually here we have a contradiction, because neither of them can be on the top of the other. But our goal is to come up with such a sort that if something can be taken, then we will take it in proper order. If we do that, then we will be able to do something with dynamic programming. So 18 is smaller than 20, so this suggests that the rate triple should be on the top, because 18 smaller than 20, so goes on the top. On the other hand, 30 is smaller than 32, so this one should be on the top, because 18 isn't smaller than anything here. This dimension will not be properly matched with some dimension there. This is a contradiction. But if we take both, we need to have a proper sort, and either of those will be correct, either sort by maximum or sort by minimum. Let's investigate sort by max. And again, we need to decide about ties properly, but that will be a detail. We sort by maximum, and we have something like 32, 23, 18. Then there would be 20, 25, 30. Then something with, let's say, maximum equal to 28. 20, 28, and 15. I sorted by the maximum, which is here 32, 30, and 28. And in this order, I claim that indeed the first one, if we take it, it will be at the very bottom. The second one, if we take it, it will be at the very bottom, unless something was already taken, then on the top of that, and so on. Now we can do transitions, or we can treat this as some kind of a graph. Because remember, even at the very beginning, without any sort, we could take those n cuboids and make a graph, directed graph, to say from which vertex we can go to which new vertex. Let me draw it. you can make some kind of graph like this one. To say that, oh, after fourth box, there can be third one. Maybe there are a lot more edges. And our goal is to find the longest path. Here it would be 4, 3, 1, 2. Or actually, not the longest path, but the path with biggest sum of values. Values being used height. And longest path in arbitrary graph is NP-hard problem. It cannot be done. It can be done if we have DAG, directed acyclic graph. If this means there is some topological sort, there is some order. Because if we can order stuff, there will be, here it would be what, 4, 3, 1, 2. If we can say that edges go only to the left, only to the right, basically only in one direction, something like that, then we can do DP on the top of that. For every vertex, if we know what's the best path up to here, we will be able to compute that best path up to every future vertex as well. Boring problem? I would say depends on your skills. It's for competitive programmers, it's rare to find an interesting coding interview problem. But yeah, we can sort by max decreasingly, ties resolved by the second max, and so on for similar reasons, and then we can do the DP. How to do it conveniently? I will every triple sort internally. R begin and R end means that it's decreasing. And then if I sort, first element of every triple is the maximum. If there is a tie, then I sort it by the second value, and so on. And only in this order it makes sense to take elements. Even more, because I maximize the total heights, it's best to say that always the first value is the height. Now, if I only cared about pairs of cuboids, I would do something like this. For every pair ij, check cuboids of I versus cuboids of j. Compare them in some way. When one can be below the other, when every dimension is smaller or equal for the first one. But we can maybe make this into a function to make the code a bit better. This, let's call it, can be this order from the bottom. Cuboids of I and j. And for now, my program will just print such a pair. Like that. Just add a, it should be private, but whatever. Add a function can be order from bottom. Every dimension needs to be smaller or equal. Yeah, greater equal for the first one, because the first one is at the bottom. That's what they told us required in the statement. And I can implement it like this, but obviously the more dimensions you have, the bigger sense, better sense it makes to make a for loop. I could, instead of that, just do for every dimension, if a for I is smaller, return false, return true. I don't know, it's a one-liner versus several lines. Theoretically this is, shorter, so maybe better, but I would say it's easier to make a mistake here. And this is more general. If you want to check for two vectors, if every corresponding element is smaller in the first vector. So we will draw an edge only if it meets the less than constraint. Exactly. This I want to treat as an edge in a graph from I to j. And then I ask about the path with best sum of values, sum of first values. Finding such a maximum path in a directed acyclic graph, it's DP. For every dp of I want to define as the maximum sum of values up to this position. dp of size n, do I have even value n? I need to create it. Cuboids. I keep misspelling this word. Cuboids.size. For every I, oh, I will just use what I have here. Instead of printing this, I want to consider transition from I to j. If I knew that up to I can get already the sum of values 1000, and I can indeed move to j, and j has value 50, then 1050 can be at j. dp of j is maximum of itself, dp of I plus the value at j, which is, it's best to take the biggest value, cuboids of j 0. Cuboids of j is a triple, but it's already sorted decreasingly. The first value is maximum. So this is like that, and I initialize everything as this. There can be path of size just one, and here I try to expand every path. Return max in dp. dp contains the best path up to vertex 0, up to vertex 1, up to n minus 1. That should work, and complexity is quadratic here because we have two for loops, one inside the other. Let's run this, fix compilation errors. Do you know what happened to William Lin? Why are you saying something happened to him? If you're just asking about lack of videos, then actually I also don't make many videos right now. For us, for neither of us, YouTube is a full-time job or something like that. For sure not for him. So, you know, when somebody is busy in their life, they don't do YouTube that much. I guess he's busy with university right now. He got to MIT. What happens if one coordinate is bigger and the other is smaller when you compare two vectors? Then false will be returned in this function. This package cannot be below the other one. Is it always optimal to take the max value of the triple as the height? Yes, because you want to maximize it. When will you visit India? I have no idea. I would like to visit any country, actually, but for the past year I didn't go abroad. Okay. Can you please summarize the approach? Yes, especially because it's very short. For every triple in the input, I sort it decreasingly. For example, this is already sorted decreasingly, but the second triple would be 95, 53, and then 37. I say then that always the first value would be possible height, second value would be some second dimension, and third dimension. If you want, because that's because of two reasons. One is height, you want to be big. If you have some package ABC and you know that it can be below DEF because A is greater or equal than D, B is greater or equal than E, C is greater or equal than F, you will not mess up all the constraints by swapping stuff around. So if you say that the first one is now EDF and the second is BAC, then still everything is true. Still B is greater than or equal to E, and so on. If this is proper configuration, where this is the top package, this is bottom package, then this is also proper configuration. So I can sort them to make the first one maximum. It's maybe what I'm saying now is an oversimplification. It's some intuition, let's say. So yeah, I say if I use this package, then 95 will be the height. You might say, but hey, this will mess up the other package. But if the other package is also sorted like that, then if one package can be below the other, then in this sorted order, they are fine as well. We sort like that. Then we sort everything by maximum, in case of ties by second maximum, and so on. So 95 would be considered first, then 50, then 45. And then we do that. We do quite standard dynamic programming for every package to know up to this package what's the best total height. We build everything from big packages to this one. It's some bottom part of the pyramid of this sculpture, something. And we say, okay, well, here we could have height 1000. Now I see that I can put this new package J at the top with value 50, with height 50. So 1050 is what I put as dp of J in this line. Polish would probably melt in Indian summer. I was in India twice, and one time was during summer. I didn't melt, but indeed it was too hot. If you had only width and length condition, how to do it? I don't know. I don't think this, first day coding interview stream is good time for me to try to make every problem harder and think about it, because likely it will be a waste of time. Can you do the above problem? Suggestion. Can you try this? Yeah, I will choose a new problem in a moment. In approach 1, how would take care that you don't take two permutations of the same cuboid? Because I think that it's impossible to take two unless some values are equal. If they guaranteed me that every triple consists of 3 distinct values, that other idea would be fine. Because if you're given 30, 50, and 20, it's not that one permutation of 3 values you will put on the top of the other. Let's try 20, 30, 50. Always, one value here will be greater than something on the other one, and the other way around, 50 versus 20. It would be okay to just replicate every package, to consider every permutation, just remove duplicates. If you have 3 equal values, then don't actually take permutations. If you have 2 equal values, don't permute them. Or just, grab 6 permutations and in some way remove repetitions. It would be fine because it's impossible to put package on the top of the same package but rotated. And there are some other facts here, like I believe that this sort can be sorted by product of all values. This is like product of 50 times 45 times 20. Whatever package you want to put at the bottom, it for sure has bigger volume than the second package. And that one has bigger volume than the third package. Except for ties, then it's equal. Sorting by product is also good. All right, next question. When you're suggesting something, please say a few words about it. Why are you suggesting it? Is it a cool problem? Is it a very hard problem, or what? I saw your suggestion. Wait, what? Okay, I see that Nadim changed their suggestion. Skyline problem. Maximum gap is a cool one. Oh, maybe not. Yeah, try to solve it in near time and space. That's a cool version, but a very hard one. I remember that in CS Academy, they have some nice hard interactive version of this problem, where really you need to do it in linear time. I will read it to remember, and then okay, that's one possibility. Mean cost to merge stones? No. this would work for storing each cuboid inside the other as well? That's correct, and maybe it would be more natural to talk about that, but then you wouldn't care about the total height. Cool problems I came across recently, yes, but cool problems for me are very hard. You can take the sum instead of product? Yes, you can take the sum. A lot of possible sorts are here. But let's try to move on. Maximum gap is one possibility. Oh, actually, I thought that Nadim and Neverending Rage are the same person. This is because of the same prefix of the nickname. Sorry about that. Should we do this, maximum gap, or something easier? Frequently used cache. The PK, you mean the LRU cache? Or something else? Please start code forces problems. I did many code forces problems in my life. I don't need to start them. If you mean that I should solve them now, then no thank you. Every day I do something particular. Today I do Leetcode problems. I don't see people requiring easier problem. So let's sort this one. It's cool. It's also cool for competitive programmers. It's one of those, when somebody requires linear time instead of n log n, that's something very unusual in competitive programming. Volume. Pierre, your pair of cuboids isn't good because heights aren't sorted. Every dimension needs to be greater for one case than the other. So yours isn't correct. Linear time usually means 2 pointers. No. Also, you cannot use 2 pointers here because sequence isn't sorted, and that's the main point. All right, maximum gap. Given an unsorted array, and that's extremely important, find the maximum difference between the successive elements in its sorted form. Return 0 if the array contains less than 2 elements. For example, 3691, well, 6 and 9 are consecutive. Those are very, very bad examples. The point is that for a sequence like 3, 8, 4, or maybe like that, you should here return 3. Even raise it by 1. Here the answer is 3 because we take those values, we imagine that they are sorted, 4, 7, 9, and then we take maximum of difference of 2 consecutive elements. Here that's 3. And easy solution is obviously sort everything, then iterate over everything except for the last element, consider nums of I plus 1 minus times of I, and that's a possible answer. Plus you need to handle the case with n equal to 0. That's trivial n log n. In competitive programming, everybody would stop at this point. But the only difficulty of this problem is that we should do it in linear time. And now you have some time to think about it. And when I tried to solve it a long time ago, I don't think I was able to do it in 5 minutes. It is a hard problem. That's simply brute force. I mean, What's brute force? Brute force here would be maybe to iterate over all pairs of values. Or like check every pair, check if there is nothing between them, something like that. I wouldn't say that n log n is a brute force. It's still quite fast solution, but too slow. They want us to get better time complexity. Should we make a copy of the array and start placing elements in the right order? How do we know it? If you're able to create a new array and place elements there in proper order, that's called sorting. And you cannot sort in linear time. Of course, there is something like radix sort. It takes the maximum value, like square root of that in the complexity. We don't want that. We don't want counting sort. Here they said that everything is up to 2 to 32, and that allows solution in complexity like n plus square root of m, where m is 2 to 32nd power, the maximum possible value of integer. But you know, they want linear, they mean O of n. Imagine a case where n is around 50, or there are like many test cases and each with 50. You don't want square root of 2 to 32. Monotone stack, but this way you would care about positions in this thing. It's not about that. With monotone stack you will find kind of an increasing subsequence of the given one. It's not like that. We need to in some way simulate the sort to understand what are two neighbors. Why 3 if max is this? Because you can read the statement. We care about maximum difference of two consecutive elements after sorting. Otherwise we would take maximum minus minimum. We can use square decomposition and split array. You're trying very hard ideas. Well, splitting into square root and then sorting is still n log n. Yes, you can use extra space, and yes, you can use multiple loops. The only requirement is time complexity should be O of n. And please don't try to achieve sorting in O of n, because that's impossible. A graph? I don't see how. What edges would you draw? But I like the fact that chat is providing so many ideas right now. That's cool. There is one stupid thing about this shaker. There is this lid part, this one, and it always has a little bit of the drink, and then when I open it, I drink it for the first time, then it drops from here. It's some very bad design of a shaker. What about getting the value while sorting somehow? If you achieve sorting, it will be n log n. You cannot sort faster. Two-pointer approach. Yeah, but what will pointers point to here? Two pointers are usually used on an already sorted sequence. Liquid? Yeah, I usually do that. I'm drinking Huel. You know, facts like observations like that are very important for an interviewer. They don't just measure your time to solve a problem, but also the way you think, and that you reasonably also reject some ideas. If you want to do something and at any moment you will have a sorted sequence, that will not be O of n. Sorting can't be done faster than n times log n. That's a small oversimplification. But because of that, we don't want to sort. How big array of I can be? Values are up to 2 to 32nd power. The constraints are written here. Counting sort isn't O of n, it's O of n plus some value. You will not sort 10 values in O of 10. You will sort 10 values in O of like 30,000. Is Leetcode the best way to prepare for jobs? It's good. If you combine it with cracking the coding interview, it's fine, more or less. But you know, it's always better to like have a person that knows all of that and you can ask them questions. How many possible gaps there would be? I mean, there will be n-1 gaps between every two values. Use map to store elements. Use map to store elements, then now loop over this map to find prefix map and suffix map, where in the prefix largest value. I think space clones, what you're suggesting is to sort it using a map. Map is n-log n. And you cannot achieve sorting better than n-log n. There are n choose 2 gaps. I mean, if you want to iterate over all pairs of values, then indeed it's n choose 2, so O of n squared, but for sure we don't want to do it. Some hash table approach. Hash table doesn't give you an order. Hash table will allow you to, for example, check if a value exists, but what will you do? When you deal with complexity and when you come up with a good, fast enough algorithm, you often should think about some long sequence and you don't know it, because computer at the beginning that it doesn't know the sequence. It can do something like sort it and then it knows that it's sorted, but it's not that it remembers all the elements at once. It can look at some elements, it can compare them. One possible solution was to sort this and then for every two consecutive elements, check their value, let's say it's 2 and 5, consider their difference, 3, to be the answer, and then move on. When moving on, we kind of forget the previous value. Now we check those two values, it's let's say 5 and 9, then we consider 4 to be the answer. Right? And if you want to use, let's say, hash table, then you need to think, okay, if I have this sequence and maybe what can I do? I can iterate over every value. If I look at this value and it's 9, how will you use a hash table? Will you check if values 10 and 8 exist? If 10 or 8 exist, then cool, you have the answer will be 1, and maybe this 8 and 10 even in unsorted are it's somewhere else, but hash table allows you to check if it exists. But if it doesn't exist, you would need to continue moving away from 9. This is, let's consider this thing, an ordered map, so a hash map of int, or just even a set. We create, I don't know how to call it, S. We create it out of nums. Then for every value in nums, we check if S exists. This is pseudocode, actually function contains doesn't exist in C++. X plus 1 or S that contains X minus 1, then something. Otherwise we check X plus 2 or X minus 2 and so on. Obviously all of that should be done with a for loop, but this is even worse than n-log n. Possibly you will get very far away from a value. Did I miss your message? I don't know. Calculating next max, next min values. How do you want to do that? Yeah, if you know next min and next max values, then sure, you solve the problem, but also this way you would achieve sorting. If for every value you are able to find next bigger value, you know the sorted array in linear time, and that's impossible. Whenever you have some idea here, think if this way you would possibly sort in O of n. If yes, that's bad. Believe me, you didn't come up with linear sorting. Map is more than linear space? I don't agree. Map is linear space. Binary search problem? It shouldn't be, because we want O of n. What's so special about cracking the coding interview? It's a good collection of advice, and it has some methods of solving problems. It isn't bad. For some reason, it is a bestseller in terms of coding interview preparation. It isn't perfect though. I bought a copy not so long ago, and I've read some of it. I saw a lot of places where I would explain it differently with a better example, or even I saw maybe like one or two real mistakes, but that's actually rare enough that you shouldn't worry about it. Would be n squared with unordered set? No, it wouldn't. I mean, if you want to here go far away, then it will be O of whatever the differences are. There can be bigger than n. I will apply to this as well. Assign the first two values of array as max so far and min so far. Now loop for other values. For every array of I, update current best answer and min so far and max so far. Well, okay, what if the first two values are 1 and 100, and then you get a lot of other values? Like you get maybe 10. So let's say that you never get values smaller or greater than 1 or 100. 85, 34, 50, 45, and so on. This will keep being min so far and max so far, but maybe the answer is the difference between two values out of those. You don't know that. It isn't enough to store min and max because you don't know if it's best to pair up with them. This conversation with chat as an interviewer is much better than you solving the problems just saying. Maybe that's a good point. Maybe I should choose problems where it's very easy to come up with an incorrect algorithm, and chat should take an interview. I give you a hard problem, you tell me stupid ideas. Actually, most of ideas that were here given aren't stupid. Just if you think about it, then you should understand why it cannot be a good idea. Because then you would sort in O of n. For example, this is a good idea because at least it doesn't imply that you were able to sort in O of n. Because that's impossible. Is it okay to ask you to explain some simple concepts like hash table? For sure not right now. Generally, and I read YouTube comments. In YouTube you can write down some idea for later. Just not during a stream. Radix sort would take 10 times n. No. Like if you want to say that logarithm of some value is constant, then no. For the same reason you can say that, well, n is limited by some value, so logarithm of n is constant. No, you want to have O of n. Iterate from 1 to 2 to 30 seconds. Yep, too slow as well. All right. Let's move forward a little bit with this. It's very important that we find maximum gap. I will tell you something. It's impossible. I don't want to put single quote because that changes the color of everything. It is impossible to compute every gap. What do I mean here? If you have a sequence, let's say this one. After sorting, all the gaps would be 9, because that's between 1 and 10. 9, what else? 12, 35, 40, and 15. I claim that it's impossible to get this sequence of differences, of gaps between two consecutive values. If you get them in this order, it would mean that you sorted the sequence, because you know that the first value is 1, and then by adding every next value, being the difference to the next value, you get every next sorted value. So that's impossible. Maybe even in messed up order, you will not really get this. N factorial to compute all gaps? No, I don't know what you want to do with all permutations of this. If you want to compute all, there is easy n log n in form of sort everything, compare every two consecutive. We shouldn't try for something slower than that. This, I claim that it's impossible to compute every gap like this one. That will be not the goal. In some way, we need to smarter find the maximum gap. The question isn't about all the gaps, it's about the maximum one. What can we do? We can, some incorrect idea first. We could binary search the answer, maybe. Binary search over the answer. And then when we have some possible answer, like 20, we would need to check if there is some gap of size at least 20. So values should be split into some small values, big values, so that the differences between them would be at least 20. It is possible here for this sequence, because I can take, for example, 110 versus 185.45. The gap between those is at least 20, so answer will be 20 or bigger. But first of all, I don't think it would be easy to check if this gap is possible, if you can split values like that. Maybe it is in linear time, I'm not sure. But even if that's the case, we already have logarithm from this part, from binary searching the answer. By the way, binary searching the answer is a very common technique, and you should know it. In sorted sequence, you can binary search some value to find some value. That's one simple use of binary search. But something else is binary searching the answer. If you are not familiar with this technique, I recommend Leetcode problem about eating bananas. Yeah, this one, cow eating bananas. If you want to know what is binary searching the answer, solve this problem. I'm sure that I already explained it somewhere on my channel. Maybe it would be hard to find. Okay, so that was a wrong idea. Other stupid idea, with a for loop you can solve. Thank you. So, like, it would be like answering a question how to cure COVID, with how to get rid of COVID. Oh, with a vaccine or with a cure. Problem solved. First loop, find max min, then use two pointers, track max and min and close the gap. But if you see 1 and 100, if they are min and max, and you see 10, then how will you close the gap? Okay. If you know that max and min are 1 and 100, and then comes 10, and then there will be more values, you don't know if now you should focus on interval from 10 to 100 or from 1 to 10. You might say that difference between 100 and 10 is big, so you should do it. But maybe later you will get all values between 10 and 100, let's say every second value. And then it turned out that after this prefix, you should have focused on values 1 and 10. What was the name of that problem again? Cow eating bananas. This one. I will give you a link as well. The cow eating bananas is a problem for binary searching the answer. Can we use the greedy technique? You can propose some greedy technique, but here I explained why one greedy solution is wrong. to go from left to right, or just to first find minimum and maximum, and then for every next value decide on which part you want to focus. If min is 1, max is 1000, and you get 10, you don't know, without looking at other values, if you need to focus on interval 110 or 1000. How binary search on answer can be O of n? It cannot. I told you that here we will not do binary search the answer because it would be logarithmic, not linear. Prefix max and suffix max? Suffix min? I mean, okay, why would this be enough? So you want maximum from prefix, and for this sequence, again, what if the very first value is maximum, the last value is minimum, and in the middle you have values in some random order, and some two of them will produce this best gap. But your idea with prefix max will always just look at 100 and always will look at 1. Remember that the order of values in the input shouldn't matter. It's suspicious that you care about prefix maximum. And if a test has very big value at the first position, it will mess up your whole algorithm. Untied Soul wrote a correct solution in the chat. Congrats. If you didn't see this problem before, then congrats. I mean, you're very close. We need to do some kind of modification of count sort. Count sort is something that doesn't have logarithm in complexity. Let's remove all of that and talk about the solution. The idea for a solution is that you cannot use sort because you don't have log. You don't want to have log, but the count sort, or also called radix sort, would be fine. But you don't want to have the range of values in complexity. So instead, let's say that you know that values are from 0 to 1000. That doesn't really matter exactly, or to million. And also you know that n is 500. Then, if values are random-ish, the gap between two consecutive values would usually be around 2000, and the maximum gap would be a bit bigger than that, maybe 5000 or so. It's not that I want to use the fact that values are random, because that's not true. Maybe there is some very malicious test. But what I will do is I will do some kind of modification, as I said, of count sort. I will create an array of size 2001, 500, I think. And this is split of interval from 0 to million into 500 intervals. Let's use exactly 500. So this is array of size n. Values from 0, so array of 0 has info about 0 to 5000, not 2000. Array of 1 has info about 2001 to 4000. And so on. And finally, array of n minus 1 has info about million minus 2000, comma million. Something like that. I imagine drawing, I can literally draw. Imagine drawing this line from 0 to max value, splitting it into n intervals, and then for every value, I can check easily to which interval it belongs, because I know the ranges. Every bucket, if values were random, every interval would have roughly one element. But that's not necessarily true. Some interval can have many. Values aren't necessarily random. But here's a huge observation. Because I used n intervals, y plus 1 there, because I started every interval from plus 1 observation, at least one interval, I want at least one interval to be empty. Is that what I want? I think so. Empty. You know what that means? It means that as answer, I will always consider minimum in some interval minus maximum in some previous interval. Like the difference of those two values. If there is at least one empty interval, then the answer is longer or equal than the length of this interval. So I don't need to consider any two consecutive elements within one interval. And that's very helpful. Maybe even one interval, it has all n elements, or like half of them. And then I cannot sort them. I cannot compare their every two consecutive values, because that's the whole problem is about that. But I don't need it. In every interval, I will just find its minimum, its maximum, and that's it. I will do it for every interval. Some of them will be empty. And I know that I have here n intervals, so what? I can have this array of size n, and I can iterate over them. I can iterate over index I of an interval. So untied soul, I see that you didn't understand the full solution, but the idea was amazing, and that's the intended solution. Let's talk a bit more about this empty thing. If you have n points and you want one interval to be empty, you need n plus 1 intervals. So maybe we need n plus 1 intervals, question mark. But actually, if the 0 and million are just two arbitrary values, that's bad. I don't want this situation. Let's say I drew my line from 0 to million, I split into n intervals, and actually all my points are here. Then I didn't solve the problem. What I want is empty interval such that there is some point on the left, there is some point on the right. So I would be able to say that answer is at least as long as one interval. What I want is to say that there is at one point here and one point there. If I know that there is some point here and there at the beginning and end, then the number of remaining points is n minus 1. If I have then n intervals, then some interval will be empty. You cannot, with that many points, fill all n intervals. No matter how they are distributed, at least one interval will be empty, and from that we get that answer is greater equal than size of one interval. Let's call it, I don't know, d. This is d. So you don't need to consider within one interval 2 points, because their distance is smaller than d, and you know that answer is greater or equal. So indeed, this should be the minimum of everything, and this should be maximum of everything. Split everything from min to max into n intervals. Not n minus 2, n. Because you want n, the number of intervals, to be greater than the number of... Oh, I made a mistake. Yeah, Chat, you're right. The number of remaining points here is n minus 2, so it would be enough to split into n minus 1 intervals. It is a very easy case of pigeonhole principle. We don't need to call it pigeonhole principle though. If you have 4 boxes and you want to put 3 items there in some order to some boxes, at least one box will be empty. I wouldn't call it pigeonhole principle. I would call it common sense. You don't need to explain it. Actually, this is called, I think, something like inverse pigeonhole principle, something like that. Because pigeonhole principle, it says that if you have 5 items and you put to 4 boxes, one box will have at least 2 items. The fact about items being fewer than boxes, that's inverse pigeonhole principle or something like that, but we just call it common sense. If there are values in all intervals, we would just be finding gaps and finding max gap. I mean, I don't get the question. But what happens here is, because of this, we know that we don't need to consider points within an interval. For every interval, as was in the previous slide, we compute minimum and maximum. And then we go through intervals from left to right. And always, from so far, we know the maximum. And when we enter a new interval, I take minimum from here. And I consider such a pair to be the answer. Because I know that answer, the maximum gap between two consecutive elements, it will be of length at least d. It will not be within one interval. Pigeonhole principle is also common sense only then? Isn't it? I think that if you take a child, let's say somebody 8 years old, and you ask them to take 3 items and put to 4 boxes so every box would have an item, they will understand that that's impossible without breaking an item. And similarly, they will understand that 5 items cannot be put to 4 boxes, so every box would have only 1 item. I would say that pigeonhole principle is among named lemmas, theorems, anything like that, it's the easiest one. Let's say that we have min. Oh, interesting. Because of this noise separation, you will not hear my keyboard. Unless I type very loudly. All right. Everything from min to max, this is our long line. We split it into n intervals. Again, it could be n minus 1, because we just care about the fact that the number of remaining points, it is smaller than the number of intervals. If that's the case, then at least one interval is empty, so blah blah blah, the fact about answer spanning across different intervals. Principle obvious, but using it in problem is tricky. Of course, everything, even adding to values, can be tricky because you might not think about doing it in some particular problem. But I don't think that it should have a name. If this... oh yeah. If we have everything from max to min. If it was from 0 to 10 to 6, and then I could get to each interval you belong by doing this. X divided by size of interval. Nums of I divided by interval size. This rounded down would give me ID of interval. For example, if interval size will be, I guess, max minus min divided by n. Maybe we should care about rounding this down or up. We will think about it later. Then I can say this. Or let's say I have some particular I ask about. For example, if interval size is 100 and you have number 330, it will be, you will get this way a 3, index 3. If you have 80, you will get 0. This is rounded down. You will get intervals indexed from 0 up. What about bouncing two items in one box? Is it something about pigeonhole principle or this problem? All right. For every I... Oh yeah, and this was if everything is from 0. If it's from min, then you care about your distance from min. If you have... If min is 150, max is something big, interval size you computed as 100, then you want things from 150 to 250 to give you index 0, the first interval of size 100, right? Actually, which interval will be nums of I minus min, like that. Like 170, you will subtract 150, you will get 20, and that this computes the distance from the very start, from the start of the whole line. And then you divide by interval size. Every item. We do this. Maybe we need to in some way exclude minimum and maximum. We will think about it later. This is which interval. And I told you that we have some array. We understand now that in every interval we care about maximum, minimum, and well, whether there is an element there. So what about we create this, we can make it a struct, some kind of bucket or interval. And it should have min and max. Let's call it small and big. I don't want to use min and max lowercase because that's keywords. Those are functions. Small, big. And also I will have the number of items in an interval to know if it's empty. Maybe this should be just Boolean value, whether it's empty or not. I create an array of intervals of size, because that's how many intervals there are. Let's remove that. And I will say intervals of which interval dot insert some value. What value do we have? Nums of I guess. Every struct interval, it has information about points within you, and it doesn't care about the exact set of points. Because remember, we cannot sort them. That would be log if there are many points in this interval. Even if they are quite evenly distributed, but sometimes we have 100 here, 1000 here, it's already logarithm of something. No. But we understand that from every interval, we just want to know if there are some points there, and what's the minimum and maximum. And after that, at the end, I will care about some edge cases. I never do that at the start. I come up with the main algorithm. I make sure I understand it and it works. At the very end, if needed, I will say maybe here, if n is 1, then return 0. I don't like doing this at the very beginning because maybe you will later switch your algorithm and you will not need such an if. Please continue algo lecture. What do you mean? You mean that I should do more things like what I did? Matrix exponentiation? Yeah, I will do that in the future. Get min and max at the same time, min-max. Yeah, that's the well-known min-max algorithm. It isn't, just in case. That's something completely else. Iterate over intervals. For every interval, if it has something, then let's take a look at the drawing again. my logic will be, if I am in interval, I consider minimum from the interval to be paired up with maximum so far. I don't know if this is 0. Maybe it should be some other value. I think min is quite safe. Answer is maximized with this. This is minimum from this interval, the leftmost point here, minus the maximum from before. And max from before becomes this. Becomes because it was obviously on the left. This interval now has the maximum. Like that. I think that other than edge cases and +-1 mistakes, maybe Ri too small by 1, we're good. I will also initialize the intervals in some way. Every interval will be small should be, I guess, int max, int min, and 0. This is infinity, then it will be minimized to something reasonable. Small will be initialized with 0. I was aware that I need to initialize intervals. This line in C++ makes a vector, you can assume that it's an array of size n, where every value is equal to this. It's interval created with values in this order: int max, int min, and 0. Infinity, minus infinity, and 0. All right. Now, what do we do with minimum and maximum? When I do max so far, I kind of already consider this minimum, so maybe I should skip it when adding to intervals. Will it hurt? Maybe even that's not necessary. If I do this, because I thought about the remaining n-2 points being in intervals, it makes sense to say that only those are in intervals, so that some interval would be empty. Maybe it also works without that. But minimum I already consider here, so it will be paired up with the first point there is. And also then answer, maximize it with max minus max so far. To consider that very rightmost point, the end of the line, with the previous point, the most recent point. Also, it resolves any issues here, because if I took max minus min divided by interval size, I'm afraid that maybe I would get some out of bounds error. I'm not that sure. But I think that now this is good. I forgot about interval in C++. Any other useful structures are pre-baked? Remember that this is just something I created. It's a new struct. This is not pre-baked. What is in C++ and it isn't in, for example, Java is a pair. Here I just created arbitrary class or struct. Semicolon. Can we insert those elements in BST and find rightmost value, blah, blah? The problem is to solve it in linear time. If you want n log n, then you could just sort the values and check every 2 consecutive ones. Means of L, nums of L. Oh, you're right. Thank you. Alcadin, you are faster than the compiler. Free, submit. Do you like these harder problems? Or should we more often do something easy? Empty input. Oh. They said return 0 if the array contains less than 2 elements. I thought for a moment what happens if it's 1 element, and I thought that everything will be alright. Max so far will be here minimum. Nothing will happen here because intervals will be empty. And here I will consider max minus min, which is 0, so nothing will happen. But indeed, nums can be empty, apparently. So I don't need to here make an if for nums size being smaller than 2, because I analyzed what happens for nums size being 1, and I think that it works. Now, similarly, I could make an if what happens if n is equal to 2. Then I could just print the difference between those two values. But I don't want to fix small cases with ifs. What do you want? Some kind of segmentation fault. We like harder problems. Seems to promote discussion. On one hand, yes. On the other, it's then harder to join the stream, isn't it? It worked for small tests. Maybe something is wrong for big values, or if there are a lot of them, or just I was lucky. I'm worried about this interval size. Let's think about it. Oh, I know. What about an assert here? To check that which interval is indeed from 0 to n minus 1. I suspect that there is some rounding issue with interval size, and because of that, this will be wrong. This assert will fail, but at least we will make sure about it. I think that now we will see random error with assert fail. Indeed. Assertion 0, blah, 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 failed. I think that which interval can exceed the allowed bounds. And maybe even I can create a test for that. How to create one? All right, here. Minimum is, let's say, 0. The maximum is 10. I want the difference to be 3. What about this? Min is 0, max is 11, so then interval size will be 3 because it's rounded down. 11 divided by n will be 3, and I think that this rounding down hurts me, because then my program thinks that intervals are 0, 1, 2, then 3, 4, 5, then 6, 7, 8, and that's it. It will not be able to hold 10, because it thinks there are 3 intervals, each of size 3. Let's run code for this small test, and I think assert will fail again. Indeed, it did. Indeed, it did fail. What is a fix? I would say that we need to round this up. So we would be sure that n intervals indeed cover the whole thing. This is how you round up. Or you could also, maybe alternative method, if this is not perfectly divisible, if modulo n this is not 0, interval size plus plus. This rounding issue is very dangerous, because maybe then my whole solution is wrong, because when we care about different sizes of intervals, maybe some lemma is not true, but everything worked. Cool. During an interview, for sure you will not get 0 points just because you rounded this to the wrong side. It's some issue with like online tests, because then if you, for example, get Codility or HackerRank test and you have 2 hours to do it, you will have some score. It's very bad if you make such a small mistake and then you don't pass tests, and you possibly even get 0 points. While during a real interview with an interviewer, you will not get 0 points, and maybe even they will not notice this. The assert part, it just what the name suggests. It makes sure that this is true, otherwise it gives you an error. Typing assert x is equivalent to doing if not x, then throw exception. Just joined, will you finish soon? Yes, I've just done this problem. And here I rounded this thing up. If max minus min is 10, and n is, let's say, 3, 10 divided by 3, rounded down would be 3, rounded up would be 4. I need 4. So my n intervals would indeed cover the whole interval from min to max. Food is ready? No, it was a dishwasher. And no, you shouldn't care about this. You should care about complexity, and that's it. Can we just multiply everything by n and it works? You will get overflows. And also then you divide by interval size, so you need to understand what really happens there. Why use assert in competitive programming? This is not competitive programming, but asserts are useful because they tell you where you made a mistake. You get some more feedback. Getting just runtime error isn't, it just says something is wrong. Getting assert failed, it means, okay, this exact claim is not true even though you thought it is. We want hard problems. You got 2 hard problems today, didn't you? Back to the list of problems. You have some suggestions? From Leetcode. Today I'm solving problems from Leetcode. Maybe next week, no, okay, next week there will be no stream because it's Christmas Eve. But I kind of alternate on Thursdays between Leetcode and binarysearch.com. The latter, it is not that well known, but it has some interesting hard problems. Yeah, Prakar is suggesting a very good thing. We can start by saying this. For every element in nums, decrease it by minimum, and then you can assume that minimum is equal to 0. Then I don't use minimum anymore. If I do this, I kind of shifted all the values to start from 0, and then remove minimum from everywhere and just take maximum. Maximum is now length of that line I have from 0 to somewhere. This minimum is 0. This is simpler formula to know which interval you belong to. You just divide value by interval size. 0. Did I remove all minimums? I think so. Assuming that minimum is 0, it helps, and we can guarantee it by shifting all the values at the very beginning. And obviously it doesn't affect the answer. The differences are the same. Leetcode, implement rand 10 using rand 7. I know that problem, but let's not do it today. Regarding this suggestion, if I solve this, I would want to talk also about some follow-ups, because this is one problem of many. There are like 5, no, maybe not 5, 3 or 4 problems related to that you should know. This is maybe the most important one. But the easier version is first to simulate rand 7 using rand 10, then you should do this. Then there are some problems about coins. So yeah, not today. Something else. Love your Polish accent. Thank you. I would prefer to have I would prefer to be native English speaker, to be honest. It will make things easier. During solving coding interviews, problems doesn't matter. but when, especially at the beginning of my streaming career, or even now during solving really hard code forces problems or something, it slows me down to speak in English. But I'm happy that some people love my Polish accent. Did I interview at trading firms? I even worked at one. It was just a summer internship, but I got a continuation offer. I declined, but yeah, I did high frequency trading. Dungeon game. I'm reading the problem, then we'll decide if it's good enough to cover. Princess is in bottom right corner of a dungeon. Knight K was initially positioned in top left room. His health point must be above 0. Right. We are interested in path between corners to so that if knights start with some quite low health points at the beginning, they still survive. And you might think that this problem is very easy because we just find the best path from start to end, like we care about the sum of values, but it isn't true, and maybe even this is counterexample. We'll understand in a moment. Which company? It was the one from Russia, AIMTech. AIMTech. This one. They have offices in Moscow and in Netherlands now, in Amsterdam. I loved the culture there. If you live nearby, I strongly recommend working there, if you can get there. Right. They say here it's optimal to move right, down, down. And if you have 7 health points, 7 HP at the beginning, you will survive. It makes sense in this grid because you want to avoid cells -5 and -10 because they will easily kill you. And this is a counterexample to a claim that we care about path with maximum sum of values. Because if this problem just said you're given a grid, find path between one corner and the other, going every time right or down, so that you would maximize the sum of values, this best path would be -2, -5, 10, 30, -5, because those values are so big. In this problem, it isn't correct, because you could already die. You don't care about your final HP. You care about the worst case in the process. And here, after doing -2, -5, you can die if you have 7 HP, while 7 HP will allow you to survive when going to the right. From 7 it will drop to 5, down to 2, up 5, 6, -5, 1. Final HP is 1. Take this example. I think that this is already a good counterexample to anything greedy. Rohit, if I want to take your example, what's special about it? There are no constraints. That's something specific for early Leetcode problems. You don't know what complexity you should have. Sounds like a classic DP problem with remembering a mean value along the way. It isn't that easy, because then you can minimize only one value at the same time, or maximize. If you went in some way to some cell, then, well, you are in some current cell. The current state is the cell, and what else? you need to track down of minimum so far to know that, oh, if I went with this path, then my lowest point was -7. So I need at least 8 HP. Means so far, and like current value or just sum of values. The issue with this state of DP is that you don't know if you should maximize second value or third, and it can be a trade-off. Actually, what I talked about here shows why this is incorrect DP. This is not good dynamic programming approach for this problem. If you want to be at the last cell and you maximize the sum of values, you will find this path with 10 and 30, even though you died earlier. If you care only about minimum so far, that's also wrong, because maybe there is some small difference between two cells. Let's say first cell is 0, then you have -1, -2. Can I actually? Yeah, let's continue. Here there is something very wrong. -10, 0, 0, and here is 5, here is 0. If you want to get from this corner, if you only maximize min so far, then in the last cell you will find this path, 0, -1, 0, 0, and whatever is here, let's say 0. Well, oh, actually this is indeed the best. Oh, yeah, and then let's put -3 here. With 3 HP, you can survive this path, while you cannot this one. There is some trade-off between those two values, and you cannot maximize them at the same time. Greedy problem, question mark, question mark, question mark. And no, Pierre, I don't think it's greedy. It's hard to decide about two values right now, like which path you should go. It very much depends on what happens later. If here from -2, you always go to bigger value, then yes, it will work in this test because you will move like that and then here. But it's very easy to create tests where it's not good. That's actually an example. From 0, it's better to take -2, just because the rest of the path is better. Oh, I need to update the link, sorry. Can we somehow binary search on the value? Yes, that's the solution. And if you don't consider this idea, the problem is very hard. You will not solve it without just thinking about it. Why do we binary search anything here? Because if you have this grid and you know your starting HP, let's say you start with 5 HP and then you go through this grid and you do something, if you find information whether you can survive or not, let's say this is impossible, you didn't survive, but you check 10 HP and yes, you survived. This is monotonic. If you survived for 10 HP, then you will also survive for 11 HP. So we can focus on binary searching the answer. Can it be negative? No, it must be at least 1. Some big value here. Low, smaller, equal, high. We will consider this middle value to be the starting HP, and then we will check if we can survive the grid. And then, cool thing is we don't care about minimum so far. When you get to some cell, you just care that you survived and you want to have the best value right now. And then we can do DP. Minimum so far isn't important anymore, because you don't care if from 5 you went down to 1 or to 2. You just want to have big value right now. How do you know this is binary searchable? I've just explained. If you can survive for 10 HP, then you can survive for 11 HP. There is some boundary. For everything up to 7 HP, for everything up to 6 HP, let's say, the answer is no. And so on. And everything above, it will be yes. 7 HP, 8 HP, and so on. So we can binary search. It's not that more HP will hurt you. Pseudocode is now if can survive, then we try to start with smaller HP, and maybe that's possible. If we didn't survive, then we need to go higher. Low is +1. This means try bigger HP. And I always implement binary search by maintaining some answer value, and it is the best found thing so far. The smallest HP for which we survive. We'll do max here. If I detect that, oh, for 10 HP I can survive, I say answer is 10, but then I will try to find answer 9 or smaller. The main difficulty is now to implement this can survive function, but that's a quite standard dynamic programming problem. Want to learn solving problems? Go to competitive, practice problems, that's it. You can, in Twitch there is command practice. It also has advice for beginners. Why would you binary search isn't that super slow compared to DP? Binary search multiplies complexity by logarithm, so that's very fast. DP is actually like n square or n cubic, so that's much slower. And the other thing is we didn't talk about any solution without binary search. So it's not that we have a choice, binary search or DP. There is no solution without binary search. Why teach people this bad mid? Because for like 10 years of my life I do competitive programming, and in competitive programming this is good enough. Yes, I'm aware how this is better, and when I did lecture on binary search I told people to use this. So for everybody information, this is better in terms of overflows. Low plus high can overflow if low and high are big, while this is good. There are still some cases where this fails, but then the other method also fails. If like this is very big and this is very small and negative. Does backtracking / shortest path not work? I explained how we don't just want a path with bigger sum of values, because here we would take this path, and that's not the best because you would die with 7 HP. And the problem, by the way, of finding such max path, it's very standard DP in the grid. So let's do the can survive. This is lambda function. This is starting HP. This should return true or false. Is this quadratic? No, it isn't. Let's rename this as grid. There is height and width. I will create DP table, 2-dimensional array, and DP of row column will be, if I can get to this cell, then what's my HP? Max HP to get to this cell. Max HP here. If I got to this cell, what's my maximum possible HP? We start with DP of 0, 0 being the starting HP. Everything else should be, I guess, infinity. What do? We minimize. Let's -1. -1, everything negative, it will denote that's impossible. That's not allowed state. Every row and column. if this is greater than 0, so if I could indeed get here, then consider moving to the right and consider moving down. Moving down. If the bottom row, the next row is still inside the grid, then consider this being here with value dp of row call plus grid of row plus 1 call. This is the value I get from going there, and this is my value right now. So this will be new HP. And what do? I maximize. And same stuff for columns. So for going to the right instead of down. Best explainer on YouTube. Thank you. That's the goal. All right. We return with our dp of this, the last cell, the bottom right corner, if we survived. This will return true or false. Also, what's the high here? I guess we should go with int max. I never like using such big values. I like when values I use are up to billion, and then I know there will be no overflows when I add 2 of them. Because now the middle can be very big. Like even here, that can overflow. Can't it? Yeah, this can overflow. That's so ugly. No upper bounds. Damn it. Actually, if there are no constraints, and now if values here are like int mean, then the answer exceeds int. I don't like this. First row and column are prefix sums. That's correct. That's a good observation. But obviously we want to initialize dp with as simple as possible. Each cell is minimum of up cell and left cell plus current. Yes, that's also alternative way to look at it. But remember, CVS, that if you do this, you need to also check if up cell and left cell, if they are positive, if you indeed could get there. If dp of some cell is -1 and dp of up cell and of the left cell is -1, and here we have value plus 20, you shouldn't take maximum of those and put here now 19. Because non-positive value means that we actually couldn't get there with surviving. So you need some ifs. Can't we go from bottom right to top left, storing how much health we need in DP? You mean to solve the whole problem? But there are two things. Not only how much health we need, or maybe? Actually, Alcadin, maybe you solved the problem without binary search. I will think about it in a moment. For me, it was obvious here that it's problem about binary searching the answer, and then it's easy. But maybe you're right that we don't need it. I will investigate this. Let's hope that high being int max -1 is enough, otherwise there is some ugly stuff like this overflowing. On the other hand, yeah, okay. This cannot happen because for sure I will survive that unless answer is really bigger than int max. What about here? Do I have... Yeah, some ugly stuff will happen because this is big. I can create tests where here long longs are necessary. Wrong answer. Oh no. Does it help if I do 100 here? I'm just checking if it's the issue is with overflows. No, it isn't. That's good. Output 5, expected 7. Well, let's read the code. What does binary search do? From 1 to int max, it finds the answer, while interval not empty. Mid is the middle of that interval. If I can survive, override the answer and try to find even lower starting HP so that I would still survive. Otherwise, I need bigger HP. What is can survive function? You get starting HP and you need to check if you can survive. Create this array with -1s. -1 means impossible to get here. There is some starting HP plus grid of 0, 0. When we start and there is, let's go -2 here, we get this penalty or the reward. The complexity is logarithm of the range of values, log of int max, here it would be 32, multiplied by whatever complexity I have here, and that's of course n squared, or actually height times width. Those are my two for loops. I just go through the grid, and for every cell I remember the best cell, the best HP to get here. All right, and now I didn't think about it, and I'm surprised, but I think that what Alkadin says will solve the problem without logarithm. Instead of binary searching the answer, we consider the problem backwards. For example, if this is -5, let's say that dp of 2 I mark as 6, and this means I need to have 6 HP to enter this cell and survive till the end. And then when I look at, let's say, this cell, this is cell dp of 1, 2, I need to have, 5 HP to get to this cell and survive till the end, because I will get +1 here, and then I need to survive further from that. So this time, I start from typing dp of h-1, w-1 is equal something, and after that I move backwards for everything like that. H was height of the grid, W is width. If this is that bottom right cell, then skip it. Maybe I don't need that. But the point is, this cell will use the right neighbor and bottom neighbor. Yeah, we will start from bottom right and take maxes kind of in it. Because if somebody tells you, imagine a big grid, this is how often you should think about solving hard problems. Not necessarily hard problems, but DP is about that. If you already computed answers for those, from this cell, what HP you need to enter this cell and survive and get here to bottom right corner, you know the same thing here. When looking at this cell, you will just choose the better option. The issue is that if I just type this, you will get some outside of the array error. Wait, I want the case where I need less HP. dp of call is however much HP I need there, but also I have some HP here. Let's say that this value in the input is 4. If now here I need 10 to survive, then here I need 6 to enter this. I think we will subtract grid of row call. Just if this is like 9 infinity or something, it's not that I need HP -50 to survive here. I need to maximize this one because they're saying that HP cannot go lower than that. So this would be enough if cells outside of the last row and the last column existed. Otherwise, I need to do some ifs, or maybe also will this work for the bottom right corner? Assuming that those two are, let's say, infinities, then it will be, yeah, that's bad. I think we need this. Let's do some trick. And instead of making ifs, let's create too big of a two-dimensional array. Instead of h by w, it will be h plus 1 by w plus 1. Again, filled with, actually I don't need to fill it because here I compute every value. dp of h minus 1 w minus 1 is what? This? If this is minus 5, then 1 minus this will be 6. Yeah, that's good. But can't go negative or 0. So maybe that's the whole solution. It would be very nice. Could we use BFS? But what do you use it? What do you want to use it for? BFS is there to find the length of the shortest path in a graph without costs of edges. There's nothing like that here. If you want to compute the number of steps from one corner to the other, it will be like height of the grid plus width of the grid, maybe minus 2. You know how many steps right and how many steps down you take. But here you have costs. If you want to think about it as graph, if anything, you would need to think about Dijkstra. Dijkstra is for weighted graph, but the problem is more complicated. There is that condition of not going below 0. So that's not just finding maximum path, and we talked about it. Yeah, Thirst, I will explain this again. What's wrong? Output 6 is expected 7. Why not just change limits to h minus 2, w minus 2? I mean, I need to populate the last row and the last column. Max of 0 and something. Don't we need to start with HP at least 1? I don't think HP of 0 is allowed. It means we die in this problem. Why are we doing max of 1? Because I cannot say that we need to enter this cell with minus 2 HP or more. Always we need at least 1 HP, hence maximum with 1. Are you and William Lin good friends? Not really, I think we barely know each other. We talked in the past, that's it. Max of 0, so you want to accept the fact that you enter some cell with HP 0? 0 means we die. 1 is the limit. You know what we will do? We will print everything that happened. For the sample test, and we will analyze what the DP found. Those are the values. 6 for this cell is correct. Then for this cell, I believe that the answer should be 5. No, right? This cell outside of the grid, actually it should be infinity. When I take here minimum of something from there and from there, I take 0. Yeah. Because I minimize, this should be the element outside of the grid. The point of making this was that now from the last row and column, I can access those values, even though those cells might not exist. Just then their DP needs to be infinity to say that's actually a very bad choice, don't do it. Right, maybe it works now. Still a very short solution. Why is it 1 minus this? Where? Accepted, cool. 1 minus grid of something, of this. Well, if I have -5 here, how much HP I need to enter this cell and survive? I need 6. Then 6 minus 5 will become 1. How did I compute 6? It's 1 plus 5. So 1 minus value here. This thing is supposed to compute 6 if this value is -5. But if this value is positive, like 10, then you will get something negative here, and you shouldn't say that, oh, I need -9 to enter this cell and survive. No, you need 1, because you cannot go below 1. Right, everybody, that was some stream full of hard problems. It isn't always like that. At least I'm not trying to make it so hard. Maybe next time it will be easier, but next time will not be in 1 week, because then Christmas break. In 2 days I will cover the Codeforces. Even in Codeforces there is the countdown now. After Codeforces round 691 I will do the post-contest discussion, and maybe also in the next few days I will do something from Advent of Code. I'm not that sure about it. In YouTube description or Twitch chat you can grab link to Discord server and to my schedule of streams. And yeah, thank you everybody for watching. That was a cool stream. We did not so boring problems because they were hardish. Wait, I need to mute this. Yeah. Let's find somebody to rate. Untied Soul. Again, congrats for getting a good idea about splitting into intervals. Thanks everybody for watching. I ended the YouTube stream, I believe.